Hi, my name is Chelsea, and today I'll be discussing my research on how different measures of anxiety and irritability may cause emotion-specific threat biases. When you see this face, would you categorize it as a happy or an angry expression? If you guessed happy or angry, you're partially right. This face is morphed with approximately 36% anger and 64% happy emotion. However, people can interpret this face differently. Some people are biased to see more threat in this face, while others might see it as happy. For example, if you categorize this face as angry, you might be more sensitive to detecting anger, which means you may have a bias towards threat. People with trait anxiety is one such group that may interpret this face differently. Trait anxiety refers to the stable tendency to experience anxiety across many situations. People with high trait anxiety have a greater tendency to interpret ambiguous emotional facial expressions as threatening. They also show differences in response times to identifying negative stimuli. This is important because having a biased interpretation of social interactions could have negative consequences and cause additional anxiety. However, less is known about how the other types of anxiety influence emotion recognition, such as state anxiety. State anxiety refers to anxiety that arises in a particular situation. It is typically short-term and can be triggered by events such as public speaking or test taking. In this study, we investigated the effects of state and trait anxiety on recognition of facial expressions. Based on previous work, we hypothesized that people with high trait anxiety and state anxiety would be biased to see these ambiguous faces as more threatening. We refer to this as having a reduced threat threshold, which indicates greater sensitivity in detecting negative emotions. Because anxiety and irritability are frequently comorbid, we also investigated effects of irritability on emotion recognition in exploratory analysis. However, we were agnostic about the direction of this relationship. For this study, we recruited a sample of 21 undergraduate students between the ages of 18 and 22. Our sample is primarily Hispanic and Asian and almost equally represented males and female. To measure participants' negativity bias, we had them complete an emotion identification task where they judged the emotion of faces more from negative to positive emotion. Pictures of 4 people expressing happiness, fear, and anger were morphed together to create 2 emotional spectra, happiness to anger and happiness to fear. Each emotion spectrum was comprised of 15 pictures. Before participating in the emotion identification task, participants completed questionnaires measuring their state anxiety, trait anxiety, and irritability using the STI state trait inventory and the brief irritability test. In each trial of the task, participants were shown a very brief picture of a face followed by a visual noise mask. Then participants reported whether the face displayed happiness, sadness, fear, or anger. We measured each participant's sensitivity to fear and anger by calculating their threat threshold. We estimated this by calculating the point of subjective equality between the 2 emotions on the spectrum via each participant's psychometric function. Fear thresholds were estimated for the happy to fear morph spectrum, and anger thresholds were estimated for the happy to anger spectrum. Each subject's threat threshold tells you at which facial expression that person's judgment switches from one emotion to another. Lower threat thresholds indicate greater sensitivity to fear or anger. For the fear to happy morphs, a low fear threshold indicates greater sensitivity to detect fear. For example, this subject begins to detect fear when the morph is around 29% fear and 71% happy, which indicates a low fear threshold. Whereas this subject begins detecting fear when the morph is about 64% fear and 36% happy, indicating a high fear threshold and a decreased sensitivity to fear. We found a significant interaction for fear thresholds between state anxiety and trait anxiety. Among people with high trait anxiety, those with high state anxiety have marginally lower fear thresholds than those with low state anxiety. However, there were no differences in anger thresholds. We also did not see differences for people with low trait anxiety regardless of their state anxiety level. Previous work finds that irritability is related to a reduced anger threshold. Surprisingly, we found that people with high irritability had increased fear thresholds than people with low irritability, which was opposite of the direction we found for people with high trait and state anxiety. However, we also found that people with high irritability were faster to label an expression as angry than those with low irritability, indicating that they may have an increased sensitivity to angry but not fearful faces. Our results indicate increased fear interpretation biases among people with high trait anxiety when state anxiety is elevated. Trait anxious people only showed negativity biases when their state anxiety was elevated, suggesting that negativity biases might be caused by temporary feelings of anxiety rather than being a stable characteristic of trait anxious people. Additionally, irritability was associated with a reduced sensitivity to fear and an increased response time to select anger. Together, these findings indicate that anxiety and irritability may be related to emotion-specific threat biases. These results are important because they help to clarify the relationship between negativity biases, anxiety, and irritability. I would like to thank Dana Glenn, Dr. Peters, and Dr. Michalska for their mentorship on this research project, as well as UC undergraduate education mini grant for funding the research.